Number 22 is a very tricky problem, but it's a very good problem. Okay, a lot of people look at it and they get very confused and they overthink it, but it's a very doable problem. Just because it has two variables and it doesn't mean it's scary. That's like having an X and a Y. And honestly, if you'd like to rewrite this with X and Y, that's okay, as long as you change your final answer to reflect that, to reflect the original variables. Okay, I'm fine with it being M and N. It's a little bit hard to say. It's hard to write them a little bit, but just be careful. This is still just distribution or window method. I'll do this one with distribution just to show that it's still going to work. So if you did the window method, that's fine. Okay? Just make sure your answer matches up and that you use the steps from this previous problem. When I do my first set of multiplications, I'm going to get a negative 5m squared. Okay? That's the same thing we'd be doing with the window method. My second multiplication gives me a positive 5mn. So a lot of people look at that and say, wait, what? How did you do that? Well, think about it. M times n. That's nothing special. It's just you write them next to each other. M, n. They don't actually multiply together like numbers would, so they just sit there next to each other. Our second set of distributions will give us positive 20 nm is how most people write this, but look, m times n and n times n, those are the same thing. So you can write it whichever way you want. Most commonly, and in fact almost all the time, we write these alphabetically. That means m comes before n in the alphabet, so we're going to write m first here. All right, mn. This is what lets us see that eventually we're going to have like terms, but first we've got to do our last distribution. That'll result in negative 20 n squared, not m, but n squared. Now, like I said, because we wrote m and n the same way both times, we can see we have like terms here and here. We combine them to get our final answer. And there we have it. Notice the front and back pieces stayed exactly the same, just like they do in the window method. The only thing you think about is where can I combine like terms? And it's not necessarily the front and back pieces, I shouldn't say that, but we have two pieces that stayed the same and two that combined. 23 is a great problem to just throw in there as like throwing a wrench into the plans, because you're sitting here going, okay, multiply, 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 multiply. And then we throw in this addition problem. It's the easiest problem of these polynomial ones for most people, but it'll trip people up because they're just thinking multiply, 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 multiply. This is an addition problem because of the addition sign between the parentheses. So all I'm doing here is looking for like terms. It's not even as hard as a subtraction problem where I had to account for that, the subtraction. I'm just looking for like terms. I see I have a 4x and a negative 4x. Those are going to combine, but really they're going to cancel. What that would be 0x, which is 0 times x, and everyone knows 0 times anything is just 0, so it's going to go away. Therefore, all that my answer is are the three pieces that are left over. 6x squared plus 3. That's a positive 3. So, tricky problem, but a good problem to throw in there. 24 is another multiplication problem. Just to keep alternating so that we see that this is true, I'm going to do this one with the window method. There's no rhyme or reason. Please hear that. There's no rhyme or reason why I'm choosing the window method. It's just a preference thing for a lot of students, so I want to show both. Do not think that, oh, I did that one with distribution. It's the same thing. Distribution is fine. I think first block, for those of you listening to this, first block has a lot of distribution people. Second and third block, it's a little bit more split, with second block even having probably more people that use the window. Okay, so it's just a personal preference thing. Let's do this one with the window theory. Or no, not the window theory, but the window method. First, we build our window. Then we stick our polynomials on it. I always stick this first one up top. I don't really know why. But be careful with the signs. That's a negative 2x. This one on the right hand or on the left-hand side is a positive 2x. So now we're ready to do our window. 7 times 7 gives us 49. 7 times 2x is 14x. 7 times negative 2x is negative 14x. Negative 2x times positive 2x is negative 4x squared. Careful, guys. I know I blow through some of these a little bit too fast sometimes, but take your time and make sure you get your variables right, okay? Now, these are our 4 terms. Again, we have like terms on the diagonal, so you can go ahead and combine them and they actually cancel out. But just for the sake of showing it, I'm going to write it all out. We've got 49 minus 14x plus 14x minus 4x squared. Now it's very apparent to see like term, and when they combine, they actually cancel because negative 14 and positive 14 is 0, just like on number 23. So what we have is 49 minus 4x squared. Again, some people like this better because the negative sign's hidden in the middle, or not hidden, but it's placed in the middle. But a lot of places are going to write this answer as negative 49x squared plus, or I'm sorry, negative 4x squared, got all sorts of tongue-tied, plus 49. That's more common, okay? Again, window theory, or the window method, not chosen for any particular reason, just showing that it still works. Notice that the window method, if you write it all the way out, this step looks a whole lot like this step up here. The window method and the distribution method really do the same exact thing, okay? 25 is a wonderful problem, okay? It's a great, great problem, and it just requires students to know one simple thing. They have to understand what square rooting is. If you see something like this on an EOC or an SAT where we're not there to help you, one simple thing will give way to what this is if you know what square rooting means. I'm sorry, not square rooting, squaring. I don't know if I said that right the first time either. Oh, getting all sorts of tongue-tied. Sorry, guys. 2 squared, this is just an example I've made up, is 2 times 2. Therefore, 3n minus 2 squared, quantity squared is how we say that, is 3n minus 2 times 3n minus 2. And once you lay it out like that, you guys are ready to rock and roll on it because it's just multiplication, just distribution, or the window. I'll do this one with distribution. I'm a little bit quicker with it. 3n times 3n is 9n squared. 3n times negative 2 is negative 6n. Negative 2 times 3n is another negative 6n. And negative 2 times negative 2 is positive 4. This is where you have to take caution. The last couple of problems, or 2 of the last recent problems, had something that canceled out because they were exact opposites, like positive 14 and negative 14. That'll trip people up here because they'll say, oh, good, those cancel. They do not. That is a negative 6 and a negative 6, okay? Negative 6 minus 6 is negative 12. So that stays in there. 9n squared minus 12n plus 4. And that's my final answer, okay?